This is a review of modeling exponential functions. Before we begin, just a quick review or reminder. Exponential functions are in the form a times b with an exponent of x. The first number, a, is the initial value, also known as the starting point or the y-intercept. The number that is the base for the exponent, usually shown inside of parentheses, that's the growth factor, or decay factor in some cases. It's how much the function is being multiplied by over and over and over again. And finally, the exponent, x, we can use to evaluate the function. So for example, something like y equals 2 times 3 to the x, often written like this, would be a function that starts at 2 and then multiplies by 3. So 2, 6, 18, 54, and so on. All right, so with that background information in mind, let's take a look at a couple problems. In the first couple, we're asked to kind of find an equivalent or the same exponential function as what's given to us. So we're asked 6 times 16 to the n, which of these is this the same as? The first thing to notice about any function is we might be able to manipulate it or rewrite it in different forms, but we can't change where a function starts. So the initial value on our equation right here is 6. It's going to have to remain 6. So we know that answer choices 2 and 4 are likely going to be our answers. The second clue that we're on the right track is to think about how the growth factor can be manipulated. If we're keeping that initial value the same, we're trying to think of which of the following is the same as 16 to the n. So, answer choice 2 says 2 to the 4n. Answer choice 8 says 8 to the 2n. Right? So we're kind of just taking away that initial value part because that's going to be the same in all of these. 16 to the n, that's the same thing as 2 to the 4th power. So, answer choice 2, 6 times 2 to the 4n, is the same thing as 16 to the n. Another way to think about this is, what's the same thing if we want to make it even a little simpler for ourselves? What's the same thing as 16? What's the same thing as 16? Well, is it 2 to the 4th? Is it 8 squared? Here we have 2 to the 4th and 4 squared, which would be okay, but again, we know that initial value has changed, which makes these no good. You're probably thinking to yourself, 2 to the 4th, that's the same thing as 16. So that's kind of another shortcut to help us identify question 2. For question number 2, about Nora inheriting a savings account, we're asked to again identify an equivalent situation to this function. Looking at the function, we might notice that we have our initial value, we have our growth factor, but this time in our exponential, we have two things being added. So if you think back to the rules of exponents, if you multiply two exponents together that have the same base, then you will add the exponents. So the correct answer here is number 4, and let's investigate that a little bit further. So notice here we have the base of 1.03. Here we have the base of 1.03. Similar to like if we had 2 to the 3rd times 2 to the 4th, we'd end up with 2 to the 7th. We'd add together 3 plus 4. If we multiply together 1.03 to the t and 1.103 to the 25, when we put them together, we would get 1.013 to the t plus 25. It's the same thing as the original function. Number 3 is no good because, well, they just distributed the t to 5,000 and left the 25 behind, and that doesn't make any sense. For answer choice 1, Well, that's no good, because in that situation, they've taken 1.013t and raised it to the 25th power. So we're no longer adding powers, we're doing a power to a power. And finally, answer choice 2 is maybe what we consider the closest, but again, here we are adding together two exponents. It's almost like if we add x squared plus 4, right? We can't put those two together. It's just like we can't put these together. So answer choice 2 isn't going to work. The only one we will be able to simplify is when we're multiplying together two numbers that have the same base. When we do that, we add the exponents and we'd end up with the same thing as the original function. Question number 3 is the same concept as the first question. In this situation, you'll notice we have our initial starting value of 15,000. In this case, every single answer has that. That part's the same. The rest of it, though, we'll notice has changed. We have 0.81 to the t. So we're asking ourselves, basically, which of these is the same as 0.81 to the t? If you do a little bit of investigation, you'll quickly discover to answer choice 2. 0.9 squared. 0.9 squared is the same thing as 0.81. 0.9 to the 9th, answer choice 1 is way too large a decimal. For answer choice 3, you'll notice they changed the exponent. And 0.9 to the t over 9 doesn't end up being the same thing as 0.81. Same thing as well for answer choice 4. We're not going to be making the exponent smaller. We're going to be multiplying by an exponent of 2. All right, for question number 4, we're again confronted with an exponential model where the initial value 300 stays the same in all of our answer choices. So we're asking ourselves, well, really, what's the same thing as 2 to the 4t? 2 to the 4th is the same thing as 16. So that answer choice 2 will be correct. Another way that you can do problems like number 4 is maybe putting p of t, this first equation, into y1 on your calculator, and then checking the table. You can then enter each of these into other parts of your graphing calculator like y2, y3, and y4, and compare it to the table and see if they're equivalent or the same. All right, lastly, in this first type of problems for number 5, we have another situation where we're given a starting value of population of 3,800. We see our growth factor and then the exponent of 7t. So again, looking through our answers, we can immediately really hone in on 1 and 2 because those have the same initial starting value. If we were to raise 1.005 to the 7th power, we would end up with 1.0035. Answer choice 2, which is correct.